Okay, a 320 kilogram rocket, 280 kilograms of which is fuel, burns all of its fuel in 32 seconds with an exhaust velocity of 780 meters per second. What are its initial and final accelerations, right? Notice I've got I tell you what the thrust is here, but I won't tell you that on the test, okay? But that's the most commonly messed up thing is people don't get the thrust right. But let's work through this methodically, right? So our initial mass is 320, right? Sitting on the launch pad with all of its fuel in it, it's got 320 kilograms of mass. Its final mass is going to be the 320, the total mass minus the fuel mass. So when the last molecules of fuel are being used up, it'll have a mass of 320 minus 280, 40 kilograms, right? Okay, the next thing we got to do is figure out the thrust of this, right? So the force times time is mass delta V. Now, the most important thing here, this is where people make mistakes, is that mass has to be the fuel mass. It's not the initial mass, it's not the final mass, it's the mass of the fuel that's burned. Okay, so that's going to be 280. Our delta V is 780 for that fuel. It burns it in 32 seconds. So remember, whenever you put a time in there, trying to figure out the thrust, this must be the time it takes that fuel to burn. So, and some of these, by the way, are going to say 5 kilograms per second. You'll see you'll put 1 second there, 5 kilograms there. Okay, so we're solving for force. So it's going to be this times this divided by that. So 280 times 780 divided by 32. And sure enough, 6825 is my thrust. All right, now we've got to draw. Now we got to figure out the initial and final accelerations. Look how straight I can draw those lines. I'm so good at this. Okay, so initially the mass is 320 kilograms. So the force downward is going to be 320 times 9.8. Let's figure that out first. 320 times 9.8. 3136 is the force downward. The force upward is going to be our 6825 that we figured out. And then we can set up Newton's second law, right? So 6825 upward minus 3136 downward equals the mass times the acceleration. And then we can solve this, right? So 6825 minus 3136, that's 3689, and then we divide by 320. So divide by 320. And I get 11.528. So 11.5. Our initial acceleration is 11.5 meters per second per second. All right. And then in the end, it's only got a mass of 40 kilograms, but it still has this crazy thrust acting on it, right? So at the end, it's got, let's draw a picture. It's really important to draw a very good rocket. Okay. So here's this upward force of 6825. The downward force is going to be so it's 40 kilograms, right? So it's going to be 40 times 9.8. So the downward force, 40 times 9.8, is 392. So it's only going to be 392 newtons of force holding this thing back. So now we're set. Now we can go 6825 minus 392, right, equals the mass, which is 40, times A. Are we ready for this? 6825 25 minus 392. I get 6433, and then if I divide that by 40, I get, holy cow. Okay, I get 160.825. Okay, don't ride this rocket, evidently, right? Like, whoa, baby. Okay, that'd be that's about 161 meters per second squared. That's crazy. That's crazy.